So now we are recording. I'm going to leave the chat window over to the side. So if you have your questions, you can put them there. Maybe I'll do it on this side. Okay. So there we go. Now I can see everybody's faces over here. I have lots of windows to like mess with. All right. So when we're talking about homeostasis, what we're really talking about is the proclivity or the necessary need to maintain a certain set of conditions in a living organism. Because while we all agree that biology is the best science and the most important science, the reality is that biology is nothing but applied chemistry. And biological organisms are built so that they can control chemical processes in certain ways. You need to maintain a certain set of conditions, environmental conditions, in order to accommodate certain chemical reactions. And that's all of what homeostasis is the super complicated system in which your body tries to maintain those conditions in different parts of the body for different reactions, and as an organism overall. So homeostasis, the word itself, means a state of equilibrium. And your cells are not just your cells, your entire organism, but even on a cellular basis, cells are able to respond to changes in order to maintain this balance. And when we're talking about cell-to-cell communication, there's a couple of different kinds. We don't get into a lot of the different types of cell signaling in IB curriculum. If you're taking 8P biology courses, they spend a lot of time talking about autocrine, which is a cell talking to itself, versus dexacrine, which is two cells talking next to each other, paracrine, and then endocrine. And endocrine is when we talk about hormones. So endocrine is when the body uses a chemical messenger to send messages over a long distance and over an extended period of time, right? So long distance communication. We need to talk a little bit about feedback, right? But maybe we'll wait for that. So this diagram is a seesaw. And it's this diagram does it for some people, but not for others.
Miss Sanford?
Yes!
You're not screen sharing.
What?
You weren't
screen sharing?
Oh my god, are you kidding me?
I thought you were just talking, and then you said diagram.
Ugh. This is not embarrassing in the slightest. Hold on. That's totally going on the video too. I am screen sharing. I'm sharing screen 1.
Oh, now it is.
Yeah, you are.
Alright. Sorry, guys. Well, anyways, everything I said still holds, so yeah. Thanks for letting me know. At least I didn't get like 10 slides in. That would be awkward. Okay. So homeostasis, again, the state of equilibrium, right? Cells can respond to stimulus in order to maintain certain conditions. Hormones are the major chemical messengers that your body uses to tell your cells to do stuff. Your cells are not smart, for lack of a better word. They need to be told what to do and when to do it. And the body uses hormones to tell cells what they should be doing and when they should be doing it. So if you look at this number diagram, number 1 is a stimulus. So if I were to walk up to Danny and poke him, that would be stimulus. And he'd be like, what are you doing? Stop, right? His skin would be the receptor because it detects a change because I poked him. The information would be sent to his brain, right? That would be 3. His brain center would be the control. And then 4 would be him going like this and being like, why did you poke me? And that's the response. So hormones work in very much the same way in your body. So there's some sort of stimulus, something that measures a particular parameter that changes. The receptor is what detects the change. That information is then sent to some sort of control center, whether that be the cerebral cortex or whether that's hypothalamus or whether that's a different part of the brain. There is a response, which is the output, right? Well, there is the output, which is information sent back, and then you get a response. And everything goes back to balance. Just a really fancy way of saying that your body responds to chemical messengers. Remember, this slideshow is available on Canvas. Somebody mute. Thank you. Okay, so let's talk about feedback. There are two types of feedback loops. If you took AP Environmental Science, you're well familiar with feedback loops. We use them quite a bit when we're talking about climate change. There are two, I just said that, there's two types, positive and negative, right? So a positive feedback loop is a cycle that feeds itself so that it keeps going, right? That's positive. Now, I don't want you to think positive and negative like good and bad. That's not what we're talking about. Positive cycle means it perpetuates itself so that it keeps on going. Negative feedback loop is the opposite. Negative feedback is where there's some sort of stimulus and then the response is effectively ends the cycle. So this is going to sound, I probably shouldn't record this, but I'm going to do it anyways because y'all are like almost adults. So the best way to remember positive and negative feedback loops is basically a drug deal. So positive feedback loop, right? You sell some drugs, you get some money, you use that money to buy more drugs, to sell more drugs, to make more money, to buy more drugs, to sell more drugs. That's positive feedback, right? The cycle is feeding itself. Or if you want to go like less inappropriate, ice cream. You have an ice cream truck and you sell ice cream and you get money from selling that ice cream. So you buy more ice cream so you can sell more ice cream. Same thing. The negative feedback loop is when you get busted and the process stops. So biological examples of this scenario would be, for positive, giving birth is actually one of the best examples. So the birth process, number one, is not fun. Number two, it's controlled by hormones. So the baby is the organism that actually initiates labor. It's not mom. Mom doesn't start labor, the baby starts labor. What happens is, eventually the baby drops, and as the baby's head pushes against the bottom of the cervix, which is right here, that causes pressure sensors in the cervix to be triggered, which is then sent to the brain. Well, wait, I should say, yeah. And then the mom releases oxytocin. Oxytocin is a hormone that gives you, actually it's a neurotransmitter, that does a couple of different things. It is called the love hormone or the bonding hormone. It is the thing that is responsible for initiating a mother-baby bond and getting you through labor, if we're just being honest. All right? So as the brain releases that oxytocin, another thing it is a neurotransmitter, the other thing that it does is it stimulates muscle contractions. So as the mom's muscles contract, that pushes the baby further down. As the baby's head pushes further down on the cervix, right? That's more pressure on the cervix. That sends a signal to the brain saying we need more oxytocin. More oxytocin is released, the muscles contract, and the process continues, right? Until you eventually push the baby out. So that's positive feedback, right? The system is feeding itself. The opposite of that is negative feedback. And the biological example for that is sweating, right? So you overheat. In response to increasing body temperature, your brain tells your skin, you should sweat. So you start sweating. As heat is absorbed from your body by the sweat and evaporated, your body starts to cool off. And as you cool off, your brain's like, okay, I'm nice and cool now. I don't need to sweat anymore. That's negative feedback. It stopped the process. Your thermostat in your house works the exact same way. So you have a temperature regulator in your house, you have a thermostat. Say you have your thermostat set to 74, right? And it's really hot and the temperature in your house goes up to 78. Your air conditioning kicks on until it brings the temperature back down to 74 degrees, and then it stops. That's negative feedback. So what I want you to do right now is I want you to take 2 minutes. I will put you in, I'll put up a breakout room for people that are online. And I want you, class people, you can work together, online people, you can work together. I want you to come up with 2 examples of positive feedback and 2 examples of negative feedback. And if you need to look them up, that's fine, but I want you to think about them and talk about them and be able to explain why they're positive and why they're negative feedback loops. So I'm going to open up a breakout room. Class people, you can start talking. And online people, I'm working on it. All right, who's left? Oh, Wes, you gotta go. Annabelle, you're at school, right? Yeah. Danny's at school. Yeah, all you guys are at school. All right, I'm gonna hop into the breakout room real quick. You guys should be discussing with each other as a class.
Well, I don't know. I don't think hiccups are a response to anything.
Cough, like if you get something stuck in your throat, and then
you stop once it's out.
Yeah, or like food poisoning. That's why you throw up.
Ooh, that's a good one. I like that. Okay, so I think in the chat, somebody said a question like biology examples. They can be biology examples. They don't have to be. So I just wanted to clarify that. I'm going to go back to the main room, talk about it a couple more, 2 positive, 2 negative, and then I'll let you know when we're coming back, okay?
All right. So do we have any?
Okay, looks like everybody's coming back. All right, so I need somebody from the classroom to unmute themselves and tell me about your one example of positive feedback that you guys came up with. In class, people. Be brave. We all know who you are. We've seen you speak before. This is not new.
We said for one of our things, it's repeating really bad. But anyways, we said because candy, like when you eat candy, releases like some sort of stuff in your brain that's like pleasure and like taste. So, is it just awful to hear me right now?
No, I got it. If you want, I know where you're going with this. I'll take it from there. I appreciate it.
It's only bad for us.
Yeah, it's not bad for us. It's only bad for you guys. You're talking about dopamine. So you're talking about addiction and dopamine.
Yeah.
Yes, that is a positive feedback cycle, right? So like you have something, you develop an addiction to it. The more you have, the more you need. Yep, totally right. That's positive feedback. Nice job.
Broadly.
Thanks, Danny. All right, so my online people, can you give me one example of negative feedback that you talked about?
We said throwing up and hiccuping.
Oh, so like you eat something bad, so your body throws up to get rid of it?
Yeah.
Yeah, so there you go. That's a great negative feedback cycle. So you ate some food, it's got bad poison in it, or it's got bacteria in it, and your stomach's like, hell no, get this out, right? So you throw up, so keep it from getting worse. I like it. Those are both excellent examples. Another classic example of positive feedback that we're going to talk about next topic, which is ecology, when we're talking about global climate change. The polar ice caps are very shiny. They reflect a lot of radiation from the sun. So as they shrink, that means we're reflecting less radiation, which means we're absorbing more radiation, which means temperature goes up, which means the ice caps melt faster. If the ice caps melt faster, that means there's less shiny surface to reflect back into space, and it's a positive feedback cycle. So melting of the glacier ice caps, or the polar ice caps, is a big deal because it feeds that positive cycle of warming. But we'll talk about that next topic. Okay, let's keep going. Nice examples. Thank you for participating in class discussions. And then Mina says, how many Adventure Time t-shirts do you have? Lily's like, she likes my LSP shirt. These are actually, I only have two. This one, and I think I'm getting more for Christmas though, so. Baby Finn is, I think, still my favorite. This is like my cranky shirt that my family makes me wear if I'm cranky. It does lump off. I'm not cranky right now though, so you're fine. Okay. All right, so let's talk about hormones, right? And we're going to talk about insulin, which is a hormone, and glucagon, which is a hormone, that are secreted by cells in the pancreas. And these are what control the blood glucose concentration in your body. So this is understanding number 1, I believe. Okay, so here's this big complicated diagram. And we're going to take it step by step.
Yeah.
Thank you. I don't know why. Oh, because when I went to the breakout room, it stopped sharing. That's why. Thank you. I don't know where to put this where it's not going to get in the way. I guess we'll put it over here. Okay, so we're going to take this step by step. Insulin. You've all heard of insulin before. It's what people with diabetes have to take to help them maintain their blood sugar. Now, insulin is produced by beta cells in the pancreas. Insulin is released by your body or released by your pancreas when blood glucose is high. So when your blood sugar is high, that triggers a release of insulin into the bloodstream. The whole job of insulin is to tell your cells, hey, you should be taking up sugar right now because there's a lot in the bloodstream. Your cells don't know what's going on in the bloodstream, right? Your cells aren't like, hey, I can see that there's glucose out here. I need to take some up. They don't know that. They need chemical messengers to tell them, hey, there's sugar out here. You should be absorbing that so that you can use it for cellular respiration. So that's the whole point of insulin. So that's why after you eat, your insulin levels increase because they tell your cells, hey, there's blood sugar available. You should be absorbing this blood sugar right now. While that's happening, your liver is also going to convert glucose, right? The C6H12O6 thing, this is glucose, into glycogen. This is extra glucose storage. And glycogen is an energy storage molecule. We learned about it in topic 2 when we talked about different types of starches in plants and animals. We learned about that one really, really huge polysaccharide that animals make. It has like 30,000 monomers. It was called glycogen. This is it. So it's a carbohydrate, lots of monomers, only made in animals, and it's stored in your liver. So that's insulin. So if you are looking at the diagram, you're looking on the right side. So you eat food, you have a high blood glucose level. That tells your pancreas, hey, you need to release some insulin. Insulin is produced by, that says alpha cells, not beta cells. That might be a mistake. We'll have to check that in a minute. Once your cells recognize there's insulin around, they start taking in blood sugar, and that reduces the overall amount of sugar in your blood. So insulin tells your cells, take sugar out of your blood. Anyone have any questions on that? Let me verify which cells actually produce insulin real quick. Yeah, it's beta cells that produce insulin. This diagram is backwards. So it is beta cells that produce insulin. So if I were you, just cross out beta on this side and put alpha, and cross out alpha on this side and put beta. I don't know why that diagram's incorrect. Hey, FYI guys, your chat is on the screen and it's recording. And yes, I think we will get a vaccine eventually. No girl fights, please. And so what if Danny likes Nicki Minaj? Leave him alone. Now. Let's keep the chat in terms of biology. All right. So now let's talk about the other side of the diagram. Let's talk about glucagon. So glucagon is produced by alpha cells in the pancreas, and it's produced when your blood sugar is low. So when you're hungry, your body produces glucagon. And that stimulates that glycogen in your liver to be broken down. And that causes your blood sugar to increase. So together, these two hormones work hand in hand to maintain a homeostatic level of blood sugar. If your blood sugar is too high, insulin tells your body to absorb some sugar and use it for cellular respiration and to store it in the form of glycogen. If your blood sugar is too low, glucagon is released, and it tells your liver to break down some of that glucagon and release it into the bloodstream so that your blood sugar is a little bit higher. So together, these two things work together to maintain a balance. Okay, so how does that relate to type 1 and type 2 diabetes? So some of you may be aware of the differences between type 1 and type 2. Do me a favor, if you're, because I can see everybody, raise your hand if you already know the difference between type 1 and type 2. Some people do, some people are like, me. Okay, all right, well, we're about to learn the difference between type 1 and type 2. And quick question, so on my screen, like half of my screen keeps like blanking out. Do you guys see that, or is it just me? Just me, okay. Okay, so diabetes is when the body is unable to decrease blood sugar levels, right? And that's a problem with insulin, because insulin is the thing that tells your body, hey, you should be taking sugar out to bring those levels down. So type 1 diabetes is actually an autoimmune disorder. It happens when your own immune system destroys the beta cells in your pancreas. So it's like your own body's defenses takes out your pancreas and is like, you don't belong here. We're not exactly sure why this happens. This is what happens in childhood diabetes. So if you know someone that has diabetes as a kid, right? This is not like lifestyle, you ate too much crap. This is like something happened, your immune system, it could be triggered after you have an illness. Your immune system goes a little haywire, gets confused, and starts taking parts of your own body out. What happens is when your body is no longer able to produce insulin, right? It's unable to absorb that blood sugar, which means that signal isn't given to cells. And we treat this by giving you insulin shots. So a friend of mine, her daughter, Finn, is like 5. She has an insulin pump. It actually automatically pumps insulin into her body when she needs it. And she has a monitor. That's permanently placed under her skin that measures her blood sugar all the time. So my friend, she has a monitor, an app on her phone it'll tell her what her daughter's blood sugar is anytime, which is really kind of cool. Type 2 diabetes is a little bit different. Type 2 diabetes is typically what you see later in life. So if you have diabetes that onsets later, right? And this isn't because your immune system attacks your pancreas. This is because your blood sugar is high more often than not. And so your body is producing and releasing insulin all the time. And when that happens, your cells start to ignore insulin, right? So you get what's called insulin resistance. This is also why it's extremely hard to lose weight for some people, depending on your age and depending on the types of food that you eat. So what happens is, it's kind of like, when your parents like nag you too much and you just tune them out at a certain point? It's exactly that. When you eat lots of sugar-rich foods all the time, that causes your blood sugar to be high all the time. When your blood sugar is high all the time, your cells are constantly being bombarded with insulin, and eventually they just stop paying attention, which means they don't know when it's time to take sugar out of your bloodstream. So your blood sugar just stays high. Now, it's not going to help if you give them shots of more insulin, because their cells aren't going to listen. This is why type 2 diabetes is such a difficult disease to treat. So really the only way to reduce the symptoms associated with type 2 diabetes is to change your diet and literally remove as much sugar from your diet as possible and hopefully reset your endocrine system so that your cells begin to lose that resistance. All right, can we keep going?
a sec. Wait a sec.
Okay. Okay, so you can answer this question in the chat or with each other. So if I just decide to have like a Dunkin' Donuts, Coolio, extra large every day, and 3 donuts, which type of diabetes am I going to get? Or you can just hold up your fingers.
2.
2. Okay. So if for whatever reason I get some sort of ridiculous bacterial infection and my immune system goes crazy and it destroys my pancreas, I could end up with which type of diabetes? Type 1. Okay. So, yeah. So be careful about making fun of people with diabetes because you don't know which kind they have, right? Don't be like, oh, you need to fix your face because you're fat because you have diabetes. Don't do that because you don't know if they have it because it's type 1 or type 2. Okay, we good now, Danny? Can we go? Just give me a thumbs up if you're done writing. Yes? Ready to go. Leif's done. Emily's still writing. Amelia's good. Wes says you probably shouldn't make fun of people at all. That's totally true. I agree. Although we all know that that's not necessarily reality. You definitely shouldn't be making fun of people because they're fat. Like, when I was a kid, the whole, like, your mom is so fat thing was, like, fun, but now not appropriate. Okay. The next hormone we're going to talk about is thyroxine. And this is secreted by the thyroid gland, and it helps regulate metabolic rate and control body temperature. So, thyroxine is a hormone secreted by the thyroid gland to help regulate metabolic rate. Colder temperatures cause the hypothalamus to stimulate thyroxine release from the thyroid, which increases metabolic rate, meaning you're going to burn more calories to generate heat. Hotter temperatures cause the hypothalamus to inhibit thyroxine release, meaning not release thyroxine, which decreases metabolic rate, which reduces the production of heat in the body. So if you had to describe this in terms of feedback, would this be positive or negative? Give me a thumbs up for positive feedback, thumbs down for negative feedback. Danny says positive feedback. Amelia says negative feedback. Mina says positive feedback. Leif said negative. Emily says positive. Lily says negative. We're split. Somebody put in the chat why they think it's positive. Come on now, y'all been blowing up the chat. Now it's going to get quiet. Zoom Rona, huh? Emily says it's a constant cycle. Mina says it's a cycle. But aren't both positive and negative cycles? I mean, they're both cycles. The question is, does the process work to feed itself or work to stop?
It feeds itself because, I mean, you always have to be hotter or colder, right? Like, I don't think there's a way you could just stop that.
How about this? Does it feed itself in one direction only?
No,
Then I
guess not.
Yeah, okay. So maybe that's a better way to explain it. And I'm glad you brought that up because a lot of people, this is a good conversation to have. So both positive and negative are cycles, meaning they continue. A positive cycle keeps feeding itself in one direction. A negative cycle seeks to stop itself or bring itself back to a certain point. Yeah, so Danny says, I thought the switch between temperatures was positive because it's constant thyroxine releases once, so it's negative. So you're split, so you're not sure. It's a negative feedback, right? It's negative. So when it's just like your thermostat in your house, and it's kind of like the sweating that we talked about. If it's colder, your body releases thyroxine, right? So that you burn more calories, so that you heat yourself up to a particular temperature. If it's too hot, your body does not release thyroxine, which brings your temperature back down. So it seeks to control temperature, right, to a specific homeostatic range. It's not running away in one direction, which is what a positive feedback does. Positive feedback just keeps going in one direction, whereas negative constrains you to a particular condition. Nope, there we go. Okay. I thought I had like arrows here, but I don't. So, hypothyroidism. Hypo means low. So, hypothyroidism is when your thyroid glands don't produce enough thyroxine. And treatment for that means taking a synthetic replacement. Some of the symptoms that are associated with hypothyroidism is poor memory and concentration, poor hearing, hoarseness of voice, slow pulse rate, which makes sense because you've got a slow metabolism. You're not burning a lot of energy. General fatigue, feeling cold all the time, right? Your circulation tends to be slower. Hair loss, shortness of breath. So it can be pretty devastating. It's kind of like turtle syndrome. Everything kind of just like slows down because your metabolic rate slows down. If your metabolic rate slows down, you're not providing energy for all these different things. Yes, I can go back. Remember, the slides are also on the Canvas page already.
So is this a negative feedback?
Mm-hmm. Yeah, anything that's trying to bring you back to a specific point is negative. So anything that's going to keep your homeostatic conditions to a certain level. Positive feedback is going to be affecting something in one direction only. Like if this were positive feedback, it would be all the way cold or all the way hot, not trying to keep you balanced.
Okay.
All right, thank you.
Cool. Okay, so there's all the stuff about hypothyroidism. Okay, the next one we're going to talk about is leptin. Ooh, and this is this one's kind of messed up. There's some scandalous science associated with this one. So leptin is secreted by fat tissue. Adipose tissue is fat tissue. And it acts on the hypothalamus to inhibit appetite. So we used leptin in a bunch of clinical trials as a diet drug with pretty disastrous effects. This was a science fail. And you can see why they would think this is good, right? Like leptin, right? The way it should work, or the way we think it works, well, the way it does work, is if you have lots of fat in your body, then you release lots of leptin, which means you should not be hungry because you have lots of fat, right? Well, there's more to the story. So here you go. Leptin is a hormone secreted by fat cells in adipose tissues, and it targets the hypothalamus of the brain, which helps control your appetite. So when you eat, it causes your leptin levels to increase, right? Which means the more you eat, the more full you get, the less hungry you are. So leptin is the thing that tells you to stop eating when you've had too much food. Some people don't produce enough leptin and they overeat. You'll hear of people that have said they've never felt hungry or not hungry. Like if food is in front of them, they'll eat it. But if it's not in front of them, they won't eat it. Like it doesn't occur to them to eat unless somebody's like, eat. But then if there is food in front of them, they never have an off switch. They never have like a I'm too full.
Does that have something to do with like binge eating disorder?
I don't know. That's a good question. I bet you it does. I bet you there's some sort of regulatory issues with leptin in binge eating. That makes sense. I would expect that you probably don't produce enough leptin. Right? So a failure to produce leptin means you're always hungry.
Yeah, like, well, sometimes people just eat a lot and then they just don't eat at all.
Yeah.
After the next.
That makes sense. I'll have to look into that. So normally the way it's supposed to work is as you eat, your brain releases leptin, and that tells you, yo, okay, I'm getting full. I should not eat so much. So scientists had this great idea. We're like, hey, why don't we use this as like a diet drug? But just like if you have insulin in your body all the time and your cells develop resistance, well, if you have leptin in your system all the time, your cells are going to develop resistance. Meaning the more leptin you have in your system, the less it works. If leptin isn't working to tell you that you're not hungry, what are you? You're going to be hungry all the time. So they were giving people leptin as a diet drug, and what happened is they just felt hungry all the time, and they ate even more. So that was a fail. So there is a positive correlation between leptin levels and obesity levels, and that's because increased levels of leptin make it hard to control your appetite. Lily, is that an article that looks at like leptin levels and binge eating?
Yes.
Sweet. You guys are awesome. I'm gonna have to check that out. Because this is an application, I would expect to see some sort of data-based question on the skills test that talks about leptin levels and correlation with obesity. Here we go. Since leptin inhibits your appetites, this is the diet drugs, right? So we're like, hey, take this shot of this hormone. You won't feel hungry anymore. And that failed. Okay. Next is melatonin. How many of you have heard of melatonin before? Raise your hand. Good. It's the sleepy hormone. Makes you nice and sleepy and happy. So melatonin is secreted by the pineal gland, and it helps regulate your circadian rhythm. And circadian rhythm means you are up during the day and you sleep at night. Otherwise known as diurnal. Di meaning 2. So instead of nocturnal, which is awake at night, diurnal, you're awake during the day, you sleep at night. Okay. In the morning, your melatonin levels are high, and in the evening, your melatonin levels are low, controlling the sleep-wake cycle. I don't think that's right. I think that's backwards.
Yeah, because don't you take melatonin pills to go to sleep?
Yeah, that's what I thought. Let's see. Well, okay. So I think I knew where I was going with that. So it's produced, your body starts producing melatonin when the sun goes down. Light is the stimulus that controls your melatonin production. So melatonin starts being produced when it gets dark and continues being produced throughout the night. Its peak production is between 2 and 4 a.m. and then it gradually falls off. So you produce it at night. So let's change this. So instead of up and down, we'll just say decrease from peak. And in the PM, melatonin levels increase with darkness. This is why some people are like, I don't know if it's like this for you, but it's like this for me. And no judgment here. I don't know why you may be awake all night. I don't care to know why you may be awake all night. But I'm the kind of person where, like, if I don't go to bed before the sun comes up, I'm not going to bed. I have to stay up. Like, my rule of thumb is I have to be in bed before the sun comes back up. Because if I see light coming over that horizon, I'm not going to sleep. I won't be able to sleep. I'll just stay up. So the rule of thumb is you be in bed before the sun comes up. Otherwise, you're not going to be able to sleep. Mina, I feel your pain. We'll do some practice questions. Maybe I can make a video with some database questions. So here we go. Light receptors in the retina communicate with the brain, being like, hey, it's light outside. Right? So here it is. There's that peak. And it's kind of interesting because even if you don't, once your body maintains this cycle and gets into this cycle pretty heavily, even if you don't have access to light, your body will repeat this cycle on its own. Which is why you feel jet lagged. Because even though you have the light cues when you travel to a different place, your body is still on the rhythm of the place where you were. And we'll talk about how you can use melatonin to treat jet lag and fix that. It's like your basic biohack. Okay, we good?
Just like one more second.
Sure.
Okay, good.
So here's just another diagram that kind of shows you different aspects of and properties that are associated with melatonin production. So things like your body temperature, changes in blood pressure, correlated with particular levels of melatonin. Now, teenagers are kind of like funky oddities because your circadian rhythm actually starts to shift compared to normal, well, compared to children younger than you and adults older than you. So your circadian rhythm starts to skew a little bit so that you tend to be more active a little bit later and tend to sleep in and be more sleepy in the morning. And that's not like a you thing. That's like a teenage thing. It's a hormonal thing that happens. And we know that that's the case, which is why I don't understand why we have high school at like 7:30 in the morning. We've changed it to 8:30 now, but when I first started teaching, like class started at 7:25. When I started teaching at Robinson, it was awful.
Yeah, we had that first.
Yeah, it was bad. But yeah, so your circadian rhythm is a little bit different than either children younger than you or adults. You are skewed a little bit more towards nighttime than adults are. And you can actually see that in your melatonin production. The timing of your melatonin production is a little bit different. And you're not going to get tested on like this stuff. This is just for your own curiosity. So jet lag happens because you're changing your sleep pattern. So your body clock, right, is off compared to the time where you are because we have human constructs like time zones, right? So your watch says, like, say you fly to California. California is behind us by like 3 hours, right? So you fly to California and you got 3 extra hours. That's not so bad. Coming back is awful, though. Transatlantic flights are awful because you're almost exactly 12 hours flip-flop, depending on where you go. So if you are flying to somewhere like Africa, right, they're about, depending on where in Africa you are, they're about 12 hours. They're exactly the opposite of us. So your body clock's like, it's the middle of the night for me. And it's the middle of the day here. So that can cause all of these things to be off. And remember, the whole point of homeostasis is controlling conditions so that you can provide the best environment for different chemical reactions to happen so you can function as a human being. And if all of those things are off, you're going to feel it. And that's what jet lag is. So in order to help correct jet lag, naturally your body will adjust about 1 hour a day. So even if you're not traveling, just when we change the clocks back and forth, an hour, think about how that screws you up, right? It takes your body 1 day to adjust for every hour off, on average. Now, in order to facilitate that process so that it happens a little bit faster, you can retrain your body by giving yourself the proper amount of melatonin at the right time. So you can train your circadian rhythm before you leave. Start adjusting your sleep cycle before you leave. That way, when you arrive, you've already adjusted. Leif, I like the black and white filter. You're very, like, film noir right now. He's got like the white button-up shirt on and the tie. You need like a hat, detective hat. I like it. So start taking melatonin before your next trip, and you won't have as much jet lag. If you have trouble sleeping, you can also take melatonin. I don't know if you develop resistance like you would. So we talked about insulin resistance and we talked about leptin resistance. I don't have any reason to doubt that if you took too much melatonin over an extended period of time, that you would probably produce, or you would probably end up with melatonin resistance as well. So I wouldn't overtake it or overuse it. Okay, we ready? Give me a thumbs up if you're ready. Lily's sleeping. I like her Z's. All right. Davey, are you recording your computer screen? Okay, how about this? So we have about, 20 minutes left. Why don't you, I'll put you back in your breakout rooms. I'll give you 10 minutes to work on these review questions. Make sure you're writing them out in your notes. If you want to take a screenshot of them right now, take a screenshot because I'm going to jump back and forth between the groups. And then shortly before class ends, I'm going to introduce you to the website for the model that we're going to use next rotation. I want you to become familiar with it before class. So you're going to have to play with the model and understand how it works before you come to class next rotation. So I'm going to open up the breakout room, give you 10 minutes to review, and then we'll come back together and look at that modeling software together. And I'm going to go make myself a cup of coffee while you guys are working.